Morning everyone, so what we're going to be using today is vectors in order to actually solve the geometrical problems. So the first thing we've actually got to know, literally all I'm going to be doing is going through the book and actually making notes as if it was in lesson time. So as you can actually see here, okay, you've got a parallelogram. What do you know about parallelogram? You know that it's got two pairs of parallel lines. But if the question's asking you to prove that this shape is not just a parallelogram, but it's actually a rhombus, what you had to actually talk about, you've got to say that AB, the length of AB, must be equal to the length of AD. That is how you would actually prove it. As you can actually see here, if AB and DC is a parallelogram, so AB and DC, so if they're equal to each other, it's a parallelogram, but if AB and AD, or as you can actually see here, BC, are equal, therefore you've actually got a rhombus. So for this shape here, you've got A, B, C and D as a parallelogram for all values of K. So you want to prove that you've got a parallelogram. So a parallelogram, what does it look like? Obviously, so A, B, C, D. So in which way could you prove that you've got a parallelogram here? Well, the way for you to actually do it is AB, prove that AB is equal to, say for example, DC. That's where we can actually do it. And also you could prove that BC is equal to AD. So it's up to you which one you would actually like to use. Second question says, find the value of K for which ABCD is a rhombus. Okay, so in order for this shape to be a rhombus, you need to have that AB must be equal to either AD or BC. Again, you've got to prove that yourselves. Okay, so how would you actually find the length of a vector? Okay, so think of using magnitude. So please feel free to pause this question here and try it yourselves. Now the answer is this. So as you can actually see here, what they've gone for AB equals to DC in order to prove that it's parallelogram. And they've gone for AB, the magnitude of AB being equal to the magnitude of BC. That's what they're trying to prove. And therefore, by using that, put one equal to each other, they were able to work out that K must be a half. So this is something that you've actually been using since GCSE. So the question was, here's point A, here's point B, and here's point C, and they were asking to prove that the A, B, C are part of the same straight line. And the way for you to actually do it in the GCSE was literally saying that AB used to find AB, and then find BC, and you prove, or even A to C, and then prove that they're actually multiples of each other. So obviously, when you're talking about vectors have got the same direction. So if they are multiples of each other and they're all starting from the same point, then they must be part of the same line. So this is what you were actually using in GCSE, and this is what we're going to be using here. So vectors lie in a straight line if they've got the same scalar. Now please try this question yourself. So you've got 3 points A, B and C. So that A, B and C lie on a straight line. So it's up to you which way you want to do it, but you need to make sure that you prove that one line segment is a multiple of a different one. This is the same question. I'm just going to show you the answers for it. Now what they've done is, you can actually see here, is they've worked out the vector AB, 9, 3, they've worked out the vector BC, 6, 2, and they've proved that they're actually multiples of each other. So BC to AB is 2/3. And then what they've done is they've used that ratio, they used that fraction in order to actually write it in ratio form, which was part B of the question. So again, something that you've been using quite a lot in GCSE level, but now we're going to start talking about position vectors, okay? So what are position vectors? Position vectors are vectors that start from 0, 0. So if you've got position vectors A and B, and you've got your midpoint M, you can use this. That will be half of A plus B. And take a minute to actually have a look at the proof also. So O to M, had O to M, well, let's find AB first of all. So AB would have to be minus A plus B. So AB would be minus A plus B. So AM must be, so AM must be half of minus A plus B. So therefore, if I wanted O to M, it must be A plus half of minus A plus B. So therefore, it's minus half A plus half B. So therefore, half of B take A. So again, the reasons to why we're using this is because it's the midpoint of a line segment connecting points with position vectors. Yeah, they are position vectors. Now, this is why we can actually use this. So again, you've got 3 points, A, B, and C, and position vector A, B, and C. So because they are position vectors, okay, what do we actually know? Well, we know that they all must start from 0, 0. So A would be here, 3 across 5 down, say for example. B will be 4 across 2 up. C would be 3 left, 1 down. Now, obviously, if I were for me to get parallelogram, it could be here or it could be there. But the parallelogram is A, B, C, D. So A, B, C, D. So therefore, I know that the point must be down there when I work it out. So find the position vector of D such as A, B, C, D's parallelogram. So in order for us to have a parallelogram, I need to make sure that these two lengths are equal. Or we can prove again that, let's say, the vectors BA, so A to B, we could say equal to C to D. So if we prove that, sorry, if we do A to B, we then want to do D to C even. If we can prove that, then we can actually prove that they're actually parallel to each other, so therefore parallelogram. Right, so I'm going to go through the answers now, so feel free to stop it and try the question or have a look at the answer. So again, they've gone here for the length of AB and DC. So MD obviously is the midpoint, is the middle, so that's why it'll be minus 4 minus 5. So let's have a look at this question. The vertices of triangle ABC have position vectors, so they have got position vectors A, B, and C. So if I wanted to work out the length of AB, so AB, what would be? AB would have to be, so A even, so that's A, that's B, that's C. And because they are position vectors, because you want M and N, so M would be here, N would be there. So we can actually use the theorem that O to M would be what? Would be half of A plus B. In a similar way, we can use the same for N. And then I want to prove that MN is parallel to BC in half its length. So therefore, you can work out what BC would actually be. And prove, you need to prove that these two are actually parallel of each other. So how would you work out BC? Well, the same way you would actually work vectors, okay? So B to C would be equal to what? Will it be equal to C take B? And then you use that in order to solve the question. So feel free to please pause the video and try a question yourselves, and then I'm going to go through the answers. Right, so answers should be, get rid of all of that. So M is the midpoint, so this is why we said half of A plus B. BC is C take B. MN will be N take M, and they've used that in order to actually prove it. Now, using anything from today, please feel free to actually complete these questions. Now, when I'm going to email you, I'm going to also send this as a worksheet. This is 5 questions on this page and 13 questions here. Now, it might be the case that we do something new on Friday. It might be the case that I actually simply go through some of these questions. So please feel free to ask me anything. All you've got to do is just literally send a picture to me and I can actually help us with a question.